You probably know more about theoretical physics than you realize. Have you ever heard of black holes? Is the equation E equals mc squared sound familiar? It's the stuff of sci-fi TV shows, or is it? Today, I'm going to discuss how theoretical physics has shaped our knowledge and how it might change our lives in the future. Theoretical physics holds the answer to all of humanity's questions, but until scientists can understand it completely, we can't use this knowledge to our advantage. Theoretical physics is split into two major divisions, the first of which is quantum mechanics, the study of things so small that we're not even sure they exist. So what does quantum mean? Well, quantum mechanics asks the question, what is the smallest building block of the universe? Can it go beyond atoms and molecules to something as small as a quanta? Quanta are so small that we can hardly understand them, but we try to figure out how they interact. The quantum world and our world have nothing in common, but the tiniest interactions in the quanta world drastically affect the world around us. Understanding these particles could lead to new inventions and technology. The second major branch of theoretical physics deals with the complete opposite, the universe, space, time, and other concepts so large that the human mind cannot even grasp them. This is contrastingly different from anything to do with quantum mechanics, but it deals with hugely important topics like wormholes and time travel and all of that. This is called relativity theory. The famous theoretical physicist Albert Einstein once mused, "I must seem like an ostrich who forever buries its head in the relativistic sand in order to not face the evil quanta." Einstein's quotation reveals the big problem. There's no way to deal with the whole universe in the same way we deal with atoms and molecules. They're just so difficult to reconcile that even Einstein was happier just ignoring the quanta because they're too difficult to deal with. Although theoretical physics is so divided, a new idea called string theory might finally be able to unify it into one cohesive field. What is string theory and why do we care? Well, string theory asserts that the smallest component of the universe is a tiny vibrating string. Now, as this chart shows, everything around us can be broken down into molecules and then into atoms and protons and whatever. And from protons, we can go down to quanta and even further to strings. This makes the universe musical in nature because everything is determined by how fast the strings are vibrating. Well, who cares? Strings give us a way of understanding interactions on small and large scales, and this could unify all the theories out there that exist. If we can manipulate these strings, or at least understand them, we can literally control every aspect of our lives. Now, despite string theory's promises, it's hardly proven anything. Lee Smolin, a professor and researcher at the Perimeter Institute for Theoretical Physics, remarks, "The paradoxical situation of string theory, so much promise, so little fulfillment, is exactly what you get when a lot of highly trained master craftspeople try to do the work of seers." Smolin's viewpoint summarizes the main criticism of string theory. It promises way more than it delivers, making string theorists nothing but fortune tellers making random guesses. Because string theory may one day help us understand the universe, it holds the potential to change our lives forever. String theory implies that there are at least 10 dimensions, including the 3 we live in. These could be tiny, complicated worlds so small that we cannot even see or interact with them. This could help understand concepts like antimatter and dark energy, which we know nothing about. And this could help explain the birth of the universe and answer all of our huge philosophical questions. We'd know a lot about theology, extraterrestrial life, and why we exist. If we can understand things like black holes and wormholes and all of that, traveling through space and time isn't as difficult as it seems. Pierre Laplace, a French astronomer and mathematician, once stated that to an intellect which would embrace in a single formula the movements of the greatest bodies of the universe and those of the tiniest atom, the future, just like the past, would be present. Laplace's quotation demonstrates the need for a way to make sense of everything we know about both the tiniest particles and the planets and stars. If we had this knowledge, there would be almost no question we could not answer. So in conclusion, theoretical physics is a varied topic. It deals with every facet of our existence. If we had just a fraction more information about the universe, we'd live in a completely futuristic society. So for all we know, in the next couple of years, there could be a scientific breakthrough that would change our lives forever. Thank you.